Okay, then let's study how to obtain the spectrum shape. So in this study, we study the Rorentz model, which is the relation between the polarization inside the material and the electric field. And this is simply the polarization induced by the electric field inside the material. And there are many dipoles induced inside the material, which is induced dipoles in a material. That makes the polarization. In the Rorentz model, the physics of the light absorption, that when the light propagates inside the material, is described. And let us think about the light propagation in the z direction and polarized in x, and then we are going to think about the simple dipole inside the object. Okay, then let me briefly going into so here's a light. Here's a light propagate, and then it's hit the molecules, for example, and molecules have an electron cloud, and that is oscillated by the electric field of the light. And when the light hit these molecules, the electron cloud is oscillated by the electric field, and that's induced a dipole, temporal dipole. And this oscillation is kind of like the mass connected with a spring, right? So it's the mass is some mass is oscillated by the spring force. So in this case, you know that equation of motion can be described like m times a equal just minus k of x if the spring constant is k, and then this distance is x, right? And then if we have some sort of the friction force is applied, so it's going to ma plus gamma v equal minus k times x, and v equal the x dt, and acceleration, of course, is d2x. So what you can obtain is m d2x d plus gamma, so new gamma, and dx dt plus m over k x equal 0. Right. So this is the equation of motion, and then you could encounter many times this type of differential equation especially for oscillation phenomena in physics. And if you have some extra force applied, for example, in this case, this one has an electron and an electron or charge, and this charge is affected by the electric field, so the 0 is changed to like 2 times et. So this is the equation we could obtain for the Rorentz model. So what we can obtain here in the Rorentz model is M T2 T2 X plus, the number is somehow used for the calculation of dt x plus x equal, the sign is also, it's a negative charge in the case like this. So as I mentioned, so this one, initial term, is corresponding to the inertial term, right? So MA, right? In the case of the mass of the spring, and this, the second term is proportional to the velocity, which is sort of the energy loss term. And this one is originally coming from restoring force, so minus kx in the case of mass of spring. And then if you have some charge, some extra force is applied in this equation. That's the force of charge. And when we think about many molecules, like if you have n dipoles considered, polarization is equal to number of dipole and E squared and E. Then this X, and then in this case, so this equation, X is changed by P, which indicate that P plus gamma dP dt plus 0 squared P equal n E squared E. So this is called Rorentz model.